You think you know your cat. You feed her every day, scratch her behind the ears, and fall asleep to her purring. You are sure there is a bond between you, that you understand her personality, her habits, and her moods. But here's the thing. Your cat lives in a world that you are physically unable to perceive, not because you are inattentive, but because your eyes, ears, and nose simply aren't equipped to see the reality in which she exists. Today, we will explore 100 facts about cats. Some of them will surprise you, some will make you see your pet in a new light, and some, frankly, might even scare you. We will move from the senses to genetics, from behavior to ecology, and conclude with what connects cats and the human brain at a level most people don't even suspect. Let's start with how a cat sees the world. The first thing to understand is that she sees it very differently than you do. Your cat cannot distinguish the color red at all. Humans have 3 types of color receptors, cones, in their retinas. One responds to red, another to green, and the third to blue. From the combination of these 3 signals, the brain constructs the rich spectrum of colors you are accustomed to seeing. Cats, however, have only 2 types of cones. They see the world much like a person with red-green color blindness, in shades of blue and yellow. That bright red toy mouse you bought at the pet store looks gray to your cat. Or a dull greenish hue. She sees nothing vibrant or appealing in it. If you really want to delight your cat with a toy, choose a blue one. But here's what your cat gains in return. While she has fewer cones, she has significantly more rods, another type of receptor responsible for light perception, than humans do. This means that a cat can see in the dark at a light level about 6 times lower than what you need. Where you stumble over furniture in a dark room, she navigates calmly, avoiding every corner. But that's not all. Behind the retina of a cat's eye lies a special layer of cells called the tapetum lucidum. It acts like a mirror, reflecting light that has already passed through the photoreceptors and directing it back, giving the cells a second chance to capture every photon. This is why a cat's eyes glow in the dark when a beam of a flashlight or car headlights hits them. It's not magic or mysticism. It's optical engineering that evolution has honed over millions of years. A cat's field of vision is wider than yours. You see the world in a range of about 180 degrees. A cat sees about 200 degrees. She notices movement where you already have a blind spot, but her visual acuity is significantly worse. At long distances, a cat sees about 6 times less clearly than you do. However, she is fantastic at detecting any movement. An immobile object at the other end of the room appears blurred and uninteresting to her. But the moment something stirs, her pupils dilate instantly, her whole body tenses, and her brain shifts into hunting mode. Cats are designed to notice what moves, because what moves is either food or danger. Now here's a detail that few people know. A cat can hardly see directly in front of her nose. She has a blind spot at a distance closer than 25 centimeters. If you place a piece of food right under her nose, she might not see it and will search by nudging her face against the floor. This isn't stupidity or caprice. It's the physics of her visual apparatus. But a cat has a tool that compensates for this shortcoming, her whiskers. Each whisker is not just a hair. It is embedded in the skin much deeper than regular fur and is connected to a separate nerve ending. Whiskers are so sensitive that they detect air vibrations created by nearby moving objects. A cat literally feels the shape of objects around her face without touching them. When she passes through a narrow gap in the dark, her whiskers act like radar, scanning the space ahead and to the sides. That's why you should never trim a cat's whiskers. For her, it's like depriving a person of their fingers. She would lose part of her perception of the world. Now let's talk about hearing. And this is where it gets really interesting. The upper limit of human hearing is about 20 kilohertz. That's the ceiling above which you hear nothing. A cat can hear sounds at frequencies up to 64 kilohertz. That's more than 3 times higher. Why does she need such a range? because it is at these ultrasonic frequencies that rodents communicate with each other. Mice and rats chatter, call to one another, warn of danger, and they do all this at frequencies that humans cannot hear at all. But a cat hears every squeak. Here's an explanation for a situation you've likely encountered. Your cat is sitting in the middle of the room. Nothing is happening. Absolute silence. And suddenly she freezes, turns her head, and starts staring intently at the wall, or a corner, or the ceiling. You look around. There's nothing there. You start to feel uneasy. Maybe the cat sees something supernatural? No. She hears sounds for which you simply have no receptors. The scratching of an insect inside the wall, the rustling of a mouse beneath the floor, the vibration of a pipe 2 floors down. To you, the room is quiet. To the cat, it is filled with sounds. But the cat has one more sense that you completely lack. On the roof of her mouth, just behind the upper incisors, lies the Jacobson's organ, a small cavity lined with receptor cells. This organ allows the cat to analyze the chemical composition of the air. You have probably seen your cat freeze with her mouth slightly open and her upper lip raised, wearing a strange expression as if she is either sniffing or feeling unwell. This is called the Flamen response. In that moment, the cat is literally tasting the air. She draws in molecules to the roof of her mouth, where the Jacobson's organ breaks them down into their components. She receives information that neither smell nor taste can provide separately. She reads the chemical portrait of the surrounding world. And one last thing about the senses, which is my favorite fact from this section. Cats do not perceive sweet flavors at all. They simply lack the receptors on their tongues that recognize sugar. This is not a malfunction or a defect. Cats lack a functioning copy of a gene called TAS1R2, the very gene responsible for the perception of sweetness in humans and most other mammals. In cats, this gene is broken, and this did not happen by chance. It is the result of millions of years of evolution as strict predators. Cats have never eaten fruits, berries, or honey. Their ancestors consumed only meat. The sweet receptor was unnecessary for them, and evolution eliminated it. So when you eat cake and your cat watches you with interest, she does not want something sweet. She may be reacting to the smell of fat or milk protein, but the taste of sugar does not exist for her at all. Here's what we have after the first 10 facts. Your cat lives in a world where the color red does not exist, yet darkness is transparent, where behind every wall a concert of ultrasound plays that you will never hear, where air can be tasted with a special organ in her mouth, and where sweetness is an empty word because evolution decided it was unnecessary for a predator. Now honestly, have you ever noticed your cat freezing and staring at a spot where there is nothing? Now you know what it means. She hasn't lost her mind. She simply lives in a reality to which you have no access. Now that you understand the world your cat inhabits, let's explore where she actually came from. Because the story of cat domestication is not a sweet tale about how ancient humans picked up a kitten and tamed it. It's a story of parallel experiments on different continents, genetic discoveries from recent years, and one very important conclusion that changes everything about our relationship with domestic cats. Let's start with the basics. All domestic cats on the planet, every single one, descended from a single subspecies of wild cat. It's called the African wildcat, or Felis libaica in Latin. This small, sandy-colored animal still lives in the regions of the Middle East and North Africa. It was there, thousands of years ago, that what we now call domestication took place. People began to cultivate grain, which attracted rodents, and the rodents drew in wild cats. The cats came on their own, not because humans called them, but because there was plenty of food near human granaries. This arrangement was beneficial for both parties. Cats eliminated pests, and for cats, it was a stable source of prey. No one was specifically taming anyone. It was a mutually advantageous coexistence that gradually, over thousands of years, evolved into what we now recognize as the domestic cat. But here's something few people know. this was not the only attempt. In China, a completely different story was unfolding simultaneously, and it ended in failure. A study conducted in 2025 by scientists from Peking University revealed something astonishing. For about 3,500 years, cats lived alongside Chinese farmers. But these were not the same cats. They were leopard cats, a completely different wild species known as Prionelurus bengalensis in Latin. They did exactly what the African wildcats did in the Middle East, approaching granaries, catching rodents, and tolerating the presence of humans. Apparently, humans tolerated them too, and perhaps even fed them. 3,500 years side by side. It seemed like this was the second independent domestication of cats. But no, after the fall of the Han Dynasty, the leopard cats simply left. They returned to the wild. 3,500 years of coexistence with humans led to nothing. No genetic changes, no taming, no formation of a new domestic breed. This parallel attempt at domestication completely failed. The true domestic cats, the descendants of that African wildcat, only arrived in China around 730 of our era via the Silk Road. Genetic analysis confirmed that their ancestors came from the Levant, from the Middle East. And here's what this means. Domestication of the cat occurred exactly once in the entire history of humanity. Once, in one place. Everything else was attempts that led nowhere. This makes the domestic cat a unique phenomenon. It also suggests that the process of cat domestication is far more fragile and random than we tend to think. Importantly, the domestic cat has changed very little genetically compared to its wild ancestor. If you compare the DNA of a domestic cat to that of a wild African wildcat, the differences are minimal, much smaller than those between domestic dogs and wolves. Humans have been reshaping dogs for thousands of years, creating breeds, altering body proportions, size, and behavior. Cats, on the other hand, have hardly been touched. They remain almost exactly as they were thousands of years ago. And this is not a metaphor, it is a genetic fact. Now let's talk about coat colors, because there has been a significant scientific breakthrough in this area recently. In 2025, two independent groups of scientists working in parallel discovered the reason behind the orange coloration in cats. It turns out that it is due to a mutation that is not found in any other animal on the planet. This mutation involves a deletion, a small segment of DNA removed, on the X chromosome, near a gene that had never before been associated with fur color. This gene is called ARHGAP36, and prior to this discovery, scientists had no idea it could influence pigmentation. The mutation appears to have occurred just once in the entire history of cat domestication. All orange cats on the planet, every single one, carry this mutation. And since the mutation is linked to the X chromosome, it manifests differently in males and females. A male cat has one X chromosome, and if that chromosome carries the orange mutation, he will be orange. A female cat has two X chromosomes, and for her to be fully orange, the mutation must be present on both. That's why the overwhelming majority of orange cats are males, and tortoiseshell cats are almost always females. They have the orange gene on one X chromosome and the black gene on the other, activating different chromosomes in various patches of skin, creating a mosaic pattern. When you see an orange tomcat or a tortoiseshell cat, you are witnessing genetics in action. Another fact that few people know, cats have around 250 hereditary genetic diseases. Many of these diseases are surprisingly similar to those found in humans. They are so alike that cats are used in scientific research as model organisms, meaning that the same diseases affecting humans are studied in them to find treatment methods. Here's an example of how coat genetics is directly linked to health. White cats with blue eyes are often deaf. This is not a coincidence or a superstition. The gene responsible for their completely white fur is associated with the development of the inner ear. It disrupts the formation of the cochlea, the organ responsible for hearing. If a white cat has a blue eye on only one side, the deafness will typically be unilateral, on the same side as the blue eye. One gene, two systems of the body, coat color and hearing, are interconnected in such a way that the failure of one leads to the failure of the other. Now, let's talk about sleep, because cats spend a significant portion of their lives sleeping, and there's a reason for that. A domestic cat sleeps anywhere from 12 to 20 hours a day. This may seem absurd, but it's a predator's strategy. A cat is a sprinter, not a marathon runner. It doesn't chase its prey for hours like a wolf. Instead, it waits, hides, and then makes one explosive sprint that requires an enormous amount of energy. The rest of its body is designed to store that energy and recover after each sprint. Hence, the long sleep. Research from 2024 confirmed that cats, like humans, go through a phase of rapid eye movement sleep, the very phase during which we dream. Scientists observed that during this phase, cats' eyes move under their closed eyelids, and their paws and whiskers twitch. Apparently, cats do dream, and those dreams are related to what they did throughout the day. If a cat spent the entire day watching birds out the window, there's reason to believe that at night it hunts those birds in its dreams. However, feline sleep is structured quite differently from human sleep. Cats are polyphasic, meaning their sleep consists of many short episodes scattered throughout the day and night. They do not sleep in one long block like we do. Even when a cat is in deep sleep, its brain continues to process sound signals from the environment. It sleeps, but it hears. The sound of a crinkling bag, a creaking door, footsteps in the hallway. The brain analyzes each of these and decides whether to wake up. This is why a cat can instantly transition from deep sleep to full alertness. It never truly switches off. Here's what we've learned. The domestic cat originated once, in one place, from one wild ancestor. All attempts to replicate this on the other side of the world have failed. Genetically, it is almost indistinguishable from its wild progenitor. Its orange fur color is a unique mutation found nowhere else. It sleeps for 20 hours because that's how a predator is designed, and in its sleep, it is likely hunting. This section is central. And perhaps the most astonishing, because here we will discuss how a cat thinks, how it communicates, and what it is capable of. The first thing to note is that scientists still do not fully understand cats, not because cats are unintelligent, but because cats refuse to participate in studies. This is no joke. It is a real scientific problem. When researchers attempt to study cats in laboratory settings, a significant number of the animals simply drop out of the experiments. They leave the testing area, they get up and walk away. A dog will sit, wait for a command, and perform a task for a treat or the owner's approval. A cat will look at the experimental setup, sniff it, turn around, and lie down in a corner. Or it may leave the room altogether. Scientists have to gather huge samples because half of the participants are filtered out even before the experiment begins. A cat only cooperates when it finds it interesting. And this, by the way, also says something about its cognitive abilities. But what has been uncovered is impressive. Cats are capable of social learning. This means they can observe the actions of another being, including humans, and replicate those actions. Studies have documented instances where cats watched their owner open a door or container and then mimicked the movement. They learn not only through their own experiences, but also through observation. This ability was previously attributed mainly to primates and certain birds. A cat knows its name. This has been proven. Japanese scientists conducted a series of experiments in which cats were presented with a set of random words of the same length and intonation as their name, followed by their actual name. The cats reacted differently to their name, by turning their ears, moving their heads, or changing their body position. Moreover, the reaction persisted even when the name was spoken by a complete stranger. A cat can distinguish its name in the flow of speech. It knows that this word refers to it. But, and here's the key point, it decides for itself whether to respond. A cat hears you. It just doesn't always feel the need to reply. And now, a fact that breaks one of the popular myths about animals. Most animals prefer what is called contra-freeloading. This is when an animal chooses to obtain food through effort, even when a bowl of free food is nearby. Rats, monkeys, birds, bears, they all prefer to solve a puzzle to get food, even when the same food is readily available. This is seen as a sign of curiosity and a need for stimulation. Cats are the only widely studied exception. They choose the bowl of prepared food and ignore the puzzle, every time. Scientists refer to this as freeloading. A cat is a scientifically proven freeloader. It is neither stupid nor lazy. It is rational. Why expend energy when food is already here? Remember when we talked about the strategy of the sprinting predator? Here it is in action. A cat conserves every calorie because in the wild, the next sprint for prey can happen at any moment. Now let's talk about purring, and here we venture far beyond what most people know. The first misconception is that purring means a cat is happy. No, not always. Cats purr when they feel good, that is true, but they also purr when stressed, when in pain, during labor, and before death. Veterinarians know that a dying cat often purrs in its final hours. Purring is not a smile. It is something much more complex. The frequency of purring ranges from 25 to 150 hertz. Remember these numbers because something important is coming. Research in vibroacoustics, the science of the effects of vibrations on living tissues, has shown that mechanical vibrations in the range of 20 to 50 hertz stimulate bone tissue growth and accelerate fracture healing. It is precisely in this range. And here's a coincidence that is likely not a coincidence. All studied species of felines, from domestic cats to cheetahs, produce strong vibrations when purring, specifically at frequencies of 25 and 50 hertz, exactly in that corridor that stimulates bone recovery. Scientists consider purring as a possible self-healing mechanism. A cat sleeps for up to 20 hours a day. Such prolonged immobility in any other animal would lead to loss of bone mass and muscle weakening. But this does not happen in cats. One hypothesis is that purring acts as low-frequency vibrational therapy, which maintains bone density even at rest. A cat literally heals itself while lying on the couch. And here's a detail that shows how seriously this is taken. The American Space Agency NASA studied the principle of cat purring in the context of combating bone mass loss in astronauts. In zero gravity, bones lose density because they are not subjected to gravity. Researchers sought a way to reproduce the effect of low-frequency vibrations to maintain skeletal health in space. The cat found this solution before the engineers did. Now let's talk about how cats communicate with each other and with you. A study from 2025 discovered something interesting. Cats with a specific genetic mutation that causes their tails to curl cannot raise them vertically. A vertically raised tail is the primary signal of friendliness in feline body language. When a cat approaches you with its tail held high like a pipe, it is saying that it is happy to see you, that it is in a peaceful mood, and that it is ready for interaction. Cats with curled tails lack this tool, but they do not get lost. They compensate, using ear positions, facial expressions, and scent markings to convey the same information through different channels. They adapt their language to fit their physical capabilities. This is a flexibility in communication that is hard to expect from an animal often considered aloof. Furthermore, cats living in different homes with varying communication habits learn to understand each other when they meet. They adjust to each other's set of signals. It's similar to how two people speaking different dialects of the same language gradually begin to understand one another. Cats have dialects, and they are capable of mastering them. Slow blinking. You have probably heard about this, but here's the scientific confirmation. Researchers have proven that when a cat slowly closes and opens its eyes while looking at you, It is a signal of trust. Scientists refer to it as a cat kiss. In the feline world, a direct, unblinking stare is a threat. It is a challenge. That's how they look before a fight. Slow blinking, on the other hand, is the opposite. It's a way of saying, I trust you enough to close my eyes for a moment in your presence. I do not see you as a danger. And the most interesting part, this works both ways. When researchers ask people to slowly blink at their cats, the cats blink back significantly more often than when a person simply looked at them with a neutral expression. You can try this right now. Look at your cat. Slowly close your eyes and open them again. If she blinks back, congratulations. You just exchanged a signal of trust in a language that is thousands of years old. Here's what we know after this section. A cat is smarter than it lets on. It knows its name, but only responds when it wants to. It learns by observing you. It conserves energy like a professional predator. Its purring may be the oldest self-healing system in nature, and it has a language in which one slow blink means more than 1,000 words. Have you ever tried to slow blink at your cat? And did you get a response? We have reached a part that most cat owners prefer to skip, because here we will discuss the fact that your purring, fluffy ball, who sleeps on your pillow and taps at water droplets in the sink, is one of the most effective predators in the history of the planet. The implications of this for wildlife are such that scientists have long been sounding the alarm. Let's start with the official status. The domestic cat is on the list of the 100 most dangerous invasive species in the world. This list is compiled by the International Union for Conservation of Nature, the leading global organization that monitors the state of biodiversity. An invasive species is one that has entered an ecosystem where it did not previously exist and has begun to cause harm. The cat made it onto this list not because it is malicious, but because humans have spread it across continents where cats did not previously exist, and it does what it was created to do: hunt. The figures that will follow are derived from a large-scale study published in one of the most authoritative scientific journals in the world, Nature Communications. Free-roaming cats in the United States alone kill between 1.3 and 4 billion birds each year, and between 6.3 and 22.3 billion small mammals, mice, voles, shrews, rabbits. This is not a mistake or an exaggeration. These are peer-reviewed scientific data. An important caveat is that the majority of these figures are attributed not to domestic cats, but to feral and wild ones. However, domestic cats that are allowed outside also contribute. In Australia, the situation is even more dire, as the Australian fauna evolved without feline predators and is completely unprepared for them. Feral cats on this continent kill around 609 million reptiles each year, 399 million birds, and over 1 billion small mammals. Australian scientists label cats as the primary threat to local biodiversity, more serious than deforestation and climate change, specifically regarding small terrestrial species. On islands, the situation is even more dramatic. Island ecosystems are closed. The species within them are unique and often lack protective mechanisms against new predators. According to the Red List of the International Union for Conservation of Nature, cats have caused or significantly contributed to the extinction of 63 animal species. This accounts for 14% of all documented cases of extinction of birds, mammals, and reptiles worldwide. 14% of all losses, and behind every single one of them is the same animal. There is a story that illustrates the scale of the problem at the level of a single individual. In New Zealand, one feral cat killed 102 rare bats in just 7 days. One cat, 1 week, 102 victims. This species was already on the brink, and one predator inflicted damage on the population that it may never recover from. And here's a story that has become a symbol of the problem. The New Zealand wrens, known as the Lyell's wren, were small flightless birds that lived on a single island. The species was discovered and described by scientists and went extinct just a few years after being found. The reason? Cats brought to the island by a lighthouse keeper. The bird could not fly, did not know about predators, and had no chance. The species disappeared forever, and it cannot be restored. Now let's delve into why the cat is so effective. And this is where things get most surprising. A cat hunts not because it is hungry. This is a crucial point that many owners do not understand. A cat's hunting instinct is not tied to the feeling of hunger. These are two different mechanisms in the brain. A well-fed cat, just given premium food, will go outside and kill a bird with the same likelihood as a hungry one. It may not even eat its catch, because killing and feeding are different processes for a cat. One is triggered by hunger, the other by the movement of a potential prey. If it moves, it must be caught. This reflex is embedded so deeply that no amount of food can switch it off. Researchers in several countries attached miniature cameras to the collars of domestic cats that were allowed outside. The results were surprising for the owners. It turned out that owners are unaware of most of what their cats do outdoors. Cats bring home less than a quarter of their catch. The rest they leave behind, partially eat or hide. That mouse or bird that your cat occasionally brings to your doorstep is just the tip of the iceberg. The actual scale of hunting is many times greater. Meanwhile, the hunting efficiency of a domestic cat ranges from 30 to 40% of successful attempts. This means that every third or fourth attack ends in capturing prey. In comparison, a lion has a lower success rate. Your 5-kilogram cat, who is afraid of the vacuum cleaner, hunts more successfully than the king of beasts. And one more figure that is astonishing. Cats are what are known as generalist predators. This means that they do not specialize in one type of prey. They eat everything they can catch. According to scientists, cats around the world hunt more than 2,000 species of animals. Among them, 347 species are listed in the Red Book as endangered or already extinct. Just 2 words, 347 species from the Red Book, and each one is hunted by the same domestic animal that is probably napping on your lap right now. But here's what I want to make very clear, because it's important. The cat is not to blame. The cat did not choose to end up in Australia, New Zealand, Hawaii, or the islands of the Pacific Ocean. It was brought there by humans. It does exactly what evolution designed it to do: hunt. It cannot stop being a predator, just as you cannot stop breathing. Cats have become an ecological disaster, not by their own doing, but because humans, without considering the consequences, spread them across all continents and islands of the planet. This is our responsibility, not the cats. And the solution lies with us as well. Controlling the population of stray cats through sterilization, keeping domestic cats indoors or in safe enclosures with outdoor access, programs for trapping and sterilizing feral colonies. This is not a question of cruelty to cats. It is a question of responsibility towards the ecosystems that we put at risk when we decided that a cute, fluffy predator could be released anywhere. Here, I want to ask a question, and it is not rhetorical. Do you let your cat outside? And if so, do you know what she does out there? Because collar cameras have shown that most owners have no idea. They think the cat is out for a stroll, sniffing the grass and sitting on the fence. But she is hunting every time she goes out the door. We are used to dividing the world into black and white. A cat is either a cute pet or an ecological pest. But the truth, as always, is more complicated. A cat is both at the same time. It can be your best friend while still being a predator that over millions of years of evolution has been honed for one task: to catch and kill everything that moves and is smaller than it. Acknowledging this does not mean you stop loving your cat. It means loving her honestly, understanding who she really is. In the final part, we will talk about a parasite that lives in the brains of 1/3 of humanity thanks to cats, how cats affect your health, and conclude with a fact that puts an end to this entire story. This section will begin with a topic that sounds like the plot of a horror movie, but it is absolutely real science. We will discuss a parasite that uses cats as the final stop in its life cycle, while simultaneously infecting the brains of billions of living beings, possibly including yours. It is called Toxoplasma gondii. This single-celled parasite is a tiny organism that cannot be seen without a microscope. Its life cycle is structured so that it can only reproduce in one place on Earth, the intestines of a cat. Nowhere else. Not in dogs, not in cows, not in humans. Only in cats does the cycle close. Only there does the parasite produce eggs that are excreted and infect the next hosts. However, the intermediate hosts, that is, those in whom the parasite lives and waits for its chance to return to a cat, can be practically any warm-blooded animals, rodents, birds, sheep, pigs, and humans. Estimates suggest that about 1/3 of the world's population is infected with toxoplasma. 1 in 3 people on Earth carries this parasite. And here's what makes this story truly chilling. The parasite needs the intermediate host, for example, a mouse, to end up in a cat's mouth. Only then can toxoplasma complete its cycle and reproduce. But mice are afraid of cats. They flee from their scent, hide, and avoid any contact. This is a survival instinct honed over millions of years of evolution. This is not advantageous for the parasite, and it has found a solution. Toxoplasma invades the brain of the rodent, not evenly, but strategically. Research has shown that the density of parasitic cysts in the amygdala, the part of the brain responsible for the fear response, can be 12 times higher than in other areas. The parasite strikes right at the center of fear, and the result is predictable. Infected mice stop fearing the smell of cat urine. Moreover, some of them begin to show something resembling attraction to that scent. A mouse that should run from a cat approaches it. The parasite has rewritten its behavior to make it easy prey. The cycle closes. But it gets even more interesting. Studies on chimpanzees, our closest relatives, have shown that toxoplasma acts remarkably precisely. Infected chimpanzees lost their fear response specifically to the smell of a leopard. Not a lion, not a tiger. Specifically, a leopard, because the leopard is a natural predator of chimpanzees in the wild. The parasite does not just suppress fear in general. It suppresses fear specifically of the predator whose intestines it needs to end up in. This level of manipulation makes one ponder how complex a single-celled organism can be. Now, the question you are already asking yourself, what about humans? If 1/3 of humanity is infected, does toxoplasma affect our behavior? The honest answer is that we do not know for sure yet, but the data is increasing, and it compels us to take this question seriously. Meta-analyses, studies that combine the results of many individual works, have shown a statistical link between toxoplasma infection and a 2.7 times increased risk of developing schizophrenia. Correlations have also been found with changes in reaction speed and certain personality traits. The proposed mechanism is related to the fact that toxoplasma increases dopamine levels in the brain, and the imbalance of dopamine between different brain systems has long been suspected as one of the factors in the development of schizophrenia. But before you start to panic, context. A large study from 2016 involving 837 participants found only minimal differences between infected and uninfected individuals across most indicators. Scientists emphasize that correlation does not imply causation. Just because two phenomena exist side by side does not mean that one causes the other. Research is ongoing, and there is no definitive answer yet. And one more important thing, for a healthy person with a normally functioning immune system, latent toxoplasma infection is considered asymptomatic. You can carry the parasite for your entire life and experience no noticeable consequences. Owning a cat, while maintaining basic hygiene, washing hands after cleaning the litter box, regularly cleaning the litter box, not allowing the cat to hunt rodents, does not pose a serious danger. This is not a reason to get rid of your pet. It is a reason to wash your hands. Now, let's flip the coin and talk about what cats provide to humans, because there is science here too, and it is surprisingly warm. Research shows that owning a cat is associated with lower levels of cortisol, the primary stress hormone in the body. People who live with cats show lower blood pressure readings. There is data indicating a reduced risk of cardiovascular events, heart attacks and strokes, among cat owners compared to those without pets. A cat beside you literally slows down the wear and tear on your cardiovascular system. Not drastically, not like a medication, but statistically significant. And here's a fact that is beautiful in its absurdity. Scientists have studied the impact of cat videos on the internet on viewers' emotional states. The result? Even watching clips of cats reduces stress levels and increases positive emotions in people. You don't need to pet a cat. You don't even have to be in the same room with one. Just watching a video of a cat falling off a table or being startled by a cucumber is enough for your brain to release a dose of good mood. That's why cat content consistently ranks at the top of views across all platforms worldwide. This is not a coincidence or a trend. It's neurochemistry. Your brain responds to cats, even on a screen, and it feels better for it. We've covered 99 facts. There's just one left, the 100th fact. According to various estimates, there are currently between 500 million and 600 million domestic cats on the planet. They are present on every continent except Antarctica. They live in the apartments of megacities and in fishing villages, in the temples of Southeast Asia and on farms in the Midwest, on ships and at lighthouses. They are everywhere, but none of these 600 million cats have been truly domesticated, not in the way dogs have been. Humans have altered dogs over thousands of years, reshaping their bodies, their behaviors, their psyches, their instincts. A dog has become a different creature compared to a wolf. A cat, however, has not. Genetically, it is nearly identical to its wild ancestor, the African wildcat, which came to the grain stores of the Middle East thousands of years ago. Its brain is structured the same way. Its instincts function the same way. Its sensory world has not changed. Your cat is a wild animal that has voluntarily chosen to live alongside you. She was not tamed. She came on her own, and she stays because it suits her needs, not because you are her owner, but because she decided so. We have traveled the entire journey from the sensory world that you cannot perceive, through genetics and evolution, through behavior and cognitive abilities, through the ecological disaster caused by humans, through the parasite that rewrites the brains of rodents, to the simple fact that a creature lives beside you that remains wild. Has anything changed in how you view your cat? Write in the comments which fact resonated with you the most. And if you've watched until the end, I think you now understand your cat a little better. Or, at the very least, you realize how little you knew about her.